Example, visualization of molecular dynamics simulation data. The goal here is to understand biology at the molecular level. There are analog approaches and solutions to this challenge. Biologists run experiments at the molecular level and try to understand behavior of molecules using experiments and nuclear magnetic resonance spectroscopy. These machines and experiments are very expensive. The whole field of computational biology attempts to address this challenge in the digital world because it's much less expensive than the analog world. As with any simulation data, all the simulation experts generate massive amounts of data. They try to use the latest high-performance computing machines. This is the interaction of lipids and proteins. See? That's what this simulation data shows, and Al-Harbi et al. Develop some visualization software to enhance understanding of this. These holes are protein and then the paths are lipid trajectories. See? The computational biologists attempt to visualize the interaction between trajectories and the proteins. Visualization of molecular dynamics simulation data. Image courtesy of Al-Harbi et al. Al-Harbi et al. Are trying to develop visualizations to help computational biologists understand the data with a special focus, in this case, on path filtering. Given the massive number of trajectories, hundreds of thousands or millions of trajectories over multiple time steps, is it possible to select a subset of those trajectories based on interesting properties that help the biologists understanding the behavior? Al-Harbi et al. Develop tools for filtering and selection of these trajectories to try to understand behavior. One example is just changing the time step of the simulation or filtering the path by its length. They can focus on shorter paths or on longer paths. They can slide the filter over to long paths or the long trajectories. The user can filter the paths based on other characteristics. They chose a few properties that they hope will be interesting for the computational biologists. One property is curvature. There are highly curved paths. The atom trajectories are actually 3 dimensions, but they're limited to a layer analogous to the biosphere such that this dimension is relatively small compared to the Zond I dimensions. They can visualize projected 2D space or the volumetric 3 space. The user can experiment with 2D versus 3D. The standard visualization packages for this are constrained to a 2-dimensional plane and they're generally not interactive.